Okie dokie, so we're back, and now we're going to get into 1.8, which is exponents and order of operations. Now, so the first part of this is going to be going through exponents and making sure you remember how exponents work, because sometimes they can be a little bit tricky and some people want to do shortcuts when they shouldn't be. So let's see what this looks like. So a shorthand for writing repeated multiplications is by using exponents. So if you're multiplying the same number times itself a bunch of times, you can write it in a shorthand using exponents. So in this case, there's 4 2's, so we can write it as 2 with a little 4 up in the corner like this. So that's the exponent. So that's the power of 2. So that's another way to think of exponents. Exponents and powers, sometimes they use those words interchangeably. So 2 to the 4th power is another way to say it. In any case, though, remember, this is what it actually means. We're actually multiplying 4 2's together. So a common mistake people make is they say, okay, well, 2 times 4 is equal to 8. Well, that's not the way you should interpret it. So you got to be careful not to do it like that. So 2 times 2 is 4, and this 2 times 2 is 4. 4 times 4 is 16. So that's where the 16 comes from. So in this example, 2 is called the base. So that's the number that's being multiplied a bunch of times, and 4 is the exponent. So, all right, so that's the basic terminology. So let's try a few problems both ways. So the first one says to write each product using exponents. So we got a bunch of 5's we're multiplying. So what would be your base and what would be your exponent in this case? Well, remember, whatever's being multiplied is your base. So that's the bigger number. And then, so what's your exponent? Well, we just count. 1, 2, 3, 4, 5, 6. So 5 to the 6th power. Done. All right, what about this one? So we got a few different numbers that are being multiplied, so we're going to have a few exponents in this expression. So we got 3 to the 2nd is right, times, we got a bunch of 2's, so 2 to the 1, 2, 3, 4, 5 of those. And then we got the 4's, and we got 3 of those, so 4 to the 3rd. All right, nothing to it. So again, really the nice thing about it is that it's just more compact. Anytime we can make things more compact in math, we like to do it. So, especially if you had like a repetition of 100 of them. You don't want to write 100 of them out, do you? So, all right, so that's going one direction. Let's spin it around and go the other direction. So if we wanted to simplify 3 to the 4th power, then we can expand it out. So we know that this is 3 times 3 times 3 times 3. And then we can break it down. So the first 3's will give us a 9. Second 3's will give us another 9. So that gets you to 81. Now keep in mind that if you could do some of these steps in your head, great. But if not, writing them out is not a bad thing to do. So how about 7 to the 3rd power? So again, by definition, it's 7 times 7 times 7. So that's going to be 49 times 7. And then we can multiply that either on the side, use a calculator, whatever you need. We should get 343. So 343 would be 3 to 7. So again, it's not 21. Be careful. Don't be tempted to multiply those together, even though you will be. So 7 to the 3rd power is 343. Negatives. Well, we're going to have negatives. In this case, though, it's pretty clear that they want this -2, and you got to do it twice. So -2 times -2. So what's that going to give you? Hopefully you're saying 4. 4, positive 4 too, because there's 2 negatives, so they're going to cancel. What about this one? Can you tell me what the sign of the answer is going to be on that one? Well, because of that exponent of 3, we know there's 3 negatives that are going to be in there. Since there's 3 negatives, we should get a negative answer. So negative 4 times negative 4 times negative 4. So the first two are going to give us a positive 16. And then that extra negative is going to make your answer negative. So we do get a negative 64. All right. So this last one, what do you know about the answer? Is it positive or negative? Yeah, it's going to have to be positive. So, all right. So let's see what we get. Negative 5 times negative 5 times negative 5 times negative 5. So let's do two of them, which will be positive. And then the next two will also be a positive. And 25 times 25 is 625. So, positive answer, just what we expected. So a nice little rule that we can kind of pull out of all of this is the following. In general, if the base is negative, so that was key, the base has to be negative. And these ones are clearly negative because it's really saying this is my base. So it's going to be positive if the exponent's even, and it's going to have to be negative if the exponent is odd. So pretty clear. Let's see if I can screw you up. So let's look at the first one. We got negative 6 to the third power. So positive or negative? Well, hopefully you're screaming negative at me. So we should get a negative. Negative 6 times negative 6 times negative 6. So that's going to be a positive 36 times a negative 6. So now we should get a negative answer, and it's going to be a negative 216. So the nice thing about just having these rules in the back of your mind, you might think they're silly, and you say, well, the calculator will take care of it. Sometimes the calculator is not perfect. So, I mean, you might forget a negative by accident, or sometimes if you input it wrong into the calculator, it'll say it's negative when it should be positive. So just having those rules in the back of your mind, you can double check it and say, oh, well, wait a minute, why am I getting a positive when it's supposed to be negative, or vice versa? So it's just good to have those rules in your mind so that way you can double check things. All right, so what about this one? It's got a little bit more meat to it, but is the answer going to be positive or negative, do you think? Well, 2 to the third power, well, there's nothing negative there, so that should be a positive result. But then negative 5 to the second, is that going to be positive or negative? Yeah, that's going to be positive. So we should get 2 to the third. Now, is that 6? No, that's going to have to be 8. It's 8. 2 times 2 is 4, times another 2 is 8. And then negative 5 to the second. Well, negative 5 times negative 5 better be a positive 25. So that's going to get you to 200. So positive answer. Ooh, how about this next one? Negative 1 to the 23rd power. Now, I bet you some of you are saying, well, that's easy, right? That's just negative 23. Nope, not negative 23. Because what is this telling you? This is saying we're going to be multiplying a bunch of negative 1s. Oops. And it just keeps going until you got 23 of them. So all those 1s, if they were all positive, 1 times 1 times 1 times 1 is just 1. So if you got 23 of them, they're still going to be equal to 1, but is it going to be positive or negative? Because there's 23, there's an odd number. It should be a negative 1. So negative 1 should be the answer to that one. Okay, one more, and I think we'll cut this video short. All right, so negative 3 to the 4th power. Well, if we go back to our rules, it should be positive, right? No, this one's going to be negative. Now you're probably saying, wait a minute, you just told me. Well, let me show you. This one does not have a negative base. That's the problem. This has a positive base. This is equal to the negative of 3 times 3 times 3 times 3. because the parentheses aren't around that -3, you can't include the negative every time you repeat it. So those parentheses are going to be really important. Look at the difference between this one and this one. There's no parentheses, so you can't include the negative on every instance of the 3. That's the trick. So in this case, it's going to be equal to -81. So it can be really tricky at times. Those parentheses are going to be very important, especially when we get to those next problems. So we'll stop here, and then we'll see the rest of the order of operations in the next video.